Thank you all for listening this podcast. This is Coding Talks with myself, Vishnu VG. I'm a .NET programmer from Thiruvananthapuram, having experience working with the different cloud vendors like Microsoft Azure, AWS and GCP. I'm a AWS community builder for storage. There are a lot of sessions which are there on this podcast. In addition to that, there is a meetup group called Coding Talks Cloud Computing, where I take sessions on different cloud technologies, and those sessions are available on my YouTube channel, which is the same name as that of this podcast. All the opinions and things that are expressed through this podcast and also in that YouTube are purely personal and do not represent any of the employer's view in any way. With that, we can start understanding the microservice architecture in more detail. In the previous episode in this podcast, we were discussing on understanding microservices with respect to the different other forms of architectures like the layered architecture, and other forms of architecture, and how service architecture and how microservice differs from those. We also talked a bit about the modular monolith, and we also entirely stressed on avoiding the distributed monolith at all cost, because it creates the complexity of distributed architecture, plus it has the disadvantages of a monolithic application. The modern trend is towards microservices, and that's the reason why we will be discussing that in these sessions. Even though that is there, still the default standard of architecture for every new application is still the monolith. That's the safe way, because microservices architecture, because it's distributed, it may not be a good fit for all kinds of business application. It depends upon the requirements of the business domain and how it wants to scale, how much team members are involved in it. Lot of different factors contribute to the selection of microservices. So it's not like a one-way solution to take, for a new application, take this microservices architecture and do with that. That's not the case. Similar to every other architecture, should have a lot of considerations and all, because it's to have a microservice architecture in place, there needs specialized effort from the architects to decide the different areas that we can split the application to different business domains, different components, and how these will be interacting with all, and the latency and all, and the monitoring, orchestration of these things are all becomes really challenging for both the developer as well as for the architect. So a careful consideration should be there in selecting the microservice. That all I hope we discussed in the earlier episode. If you are interested in listening that episode, feel free to have a look at those as well. Continuing from the previous episode, we will be having a quick recap of what is a layered architecture or an entire architecture, and from there we can start understanding more about the microservice architecture in more detail. Some of my friends asked me the layered architecture they are working, isn't it also a kind of a microservice architecture? The answer is no, because there in the layered architecture, the partition is based on technical domain. If your application code base has different technologies associated with it. Here the main focus in layered architecture is actually the technical technologies that your application are actually used. Your application, let's say for example, if it's a web application, your application may have a front end which is developed using JavaScript or some other JavaScript libraries or framework like React. Might be it have a server-side component which has these business related things in place, and also there will be a database that will be interacting, and some form of database related code will be there. Your application has these different areas, and in the case of layered architecture, you will be splitting your application based on the technology. So you'll be ideally at a minimum have 3 different layers. One for presentation layer for the UI, then for the server side, that's the business area where your core business logic remains, and then the database layer where the persistent part is handled. And if you look at this, we can go a bit more detail into the layer architecture. If you look at a more detail into this form of architecture, you can see that actually this architecture closely mirrors that to the organization structure. And that's the reason why once it was very popular. Because your organization have different specialists working in each of these technologies, like the database or server side or front end. And if you split your application based on these different technical areas, it will be easy to give ownership for each teams to look on these different individual areas. And that will be fine when it comes to maintaining the application. But the problem happens is like if there is a simple change required in one area, it requires coordination from other areas as well. And if you know working in an organization with a different teams apart, coordination is required, and there in the layered architecture, it's actually results in a kind of an organization silos where one specialized team that is focused on database will be focusing on that particular area only, and whenever there is a change required in the front end, that needs to be communicated to the back end and vice versa. So that results in a lot of coupling. There will be a tight coupling between these different layers, and also the cohesion or the way by which the code grouping is actually there, but it is actually based on purely technical domain and not based on the business domain. Everyone who is having ownership of these different areas will be working to complete their activity. So this kind of architecture, in this layered architecture, employees are working to meet their particular area in silos, and mainly they are focusing on the activity they are doing, and it requires extra coordination, as I said earlier. And also the customer quality or the outcome is not considered here, because from the customer point of view, they want some feature there, but these individual teams are focusing on their own area. So finally, to have a good outcome, it requires the support of all the different teams. That will be challenging. Then evolved another form of team called the outcome oriented team. This can also be known as the feature-based team, where instead of each team owns a specified area of software, they own to deliver a feature. So this is the kind of approach of a poly-skilled team where multiple specialists who have experience working with the different areas like the database, server-side developers and the front-end developers all comes together into a single team, like a modular team, and then they will try to deliver a feature, and the entire team owns that feature. So the idea here is to reduce the ticketing system at all. Like as in the previous case, with the layered architecture, if it's owned by a separate individual team, other teams needs to contact them or to raise support tickets for their help to do something or something like that. But in this case of feature-based team, that individual team will have a combination of people from different areas like the database specialist and all, database, the server side and front end and all, and that way they can together as a team they can focus on the delivery of a feature instead of depending on other teams for that activities. So that's the evolution coming up in software architecture, from the layered to the feature outcome oriented team, and from there actually another form of architecture evolved. So this is also known as actually a stream aligned teams. This feature based team is also known as stream aligned team, where they are focused on a particular feature or the valuable stream of work of their product. For example, if there is a purchase area that they needs to deliver in their application, a set of teams, like a poly-skilled team, team members can coordinate that activities and deliver the feature to the customer. That's called the stream aligned team. And similarly, if there is a stock management needs to develop in an application and needs to deliver, then a set of teams can work on that area, stock management area, and they can deliver the features. That way, the silo concept can be broken down and can be moved into a stream aligned team. But still, if you are looking on this stream aligned team, if you look at the architecture, underneath architecture where they are working on, that is still a kind of an architecture called the layered approach. So the organization stream structure has evolved from layered based specialist team to the feature based team. Still, the underlying code splitting where they are working on is actually based on technical, so that node won't sync properly, and that's the reason why some other form of architecture splitting is required, and that's how the microservice architecture came into more popularity. For the stream based development, this microservice architecture would be definitely helpful. The service oriented architecture is also helpful for that, but there is a difference. As in the case of a service oriented architecture, there are no such considerations like a individual database or an individual deployment. Individual deployment should be there, as in the case of a microservice. So there is a difference, there is a line of difference between the service oriented architecture and with that of the microservice architecture. In microservice architecture, it should have a modular, it should be a modular service which should stand independently. It is developed independently and tested independently and also deployed in isolation without affecting the other components. It should have a dedicated database for that particular microservice. Whereas in the case of a service oriented architecture, these things are not there, or these things are not mandatory. So that's the core difference with a microservice as well as a service based architecture. So we in this episode will be focusing more on the microservice architecture in more detail, because that's the more accurate architecture, best aligned for a stream based development. Like the stream based team will have a group of different peoples working in together, like a group of poly skilled people with their own expertise, and for them to having an ownership of a single business domain in the application will be helpful. So an architecture that meets that kind of development will be helpful for them, and microservice architecture will be the best fit for them. The service oriented architecture, as we discussed, has some different characteristics, like they share database and individual deployment is not a concern. That is not best fit for a stream aligned team at all, because stream aligned teams needs to work in isolation independently, and they need to deliver without affecting the other area. That's the reason why microservice would be the best, more apt service for them to deliver the feature. They can also work on the stream aligned teams can also work on service based architectures, but this one will be the better choice for them. But even though that is still the case, like the experts say, like Sam Newman says, the default or standard for every new application should be the monolithic application or some other kind of architecture, because microservice has its complexity as we discussed earlier. So we cannot push forward microservice architecture to every application. It depends upon the number of teams that we have, the amount of scalability that we need for an application, And considering all those factors only, we can have microservice architecture in place. When it comes to a distributed architecture like a microservice architecture, there will be more challenge in orchestrating these things, coordinating these things, error handling, the network, to handle the network delay, latency and all. So specialized architectural considerations are required, and that brings more complexity. That's the reason why many experts say that as you are progressing with this microservice architecture implementation, you would be encountering lot of problems. So it's not a de facto standard for every new application. That is the thing you need to consider, because the Kubernetes and the serverless architecture are popular these days. Many would be thinking about, okay, when we start developing an application, let's take a microservice architecture and start like that. It should not be the case. There should be a proper analysis, and if it has a scope of expandability, and if there are more team members involved in that kind of application development, then microservice will be a good fit for them. Otherwise, it would be an overkill. Then the next area we are going to discuss is to understand how we split the code. We are focusing on splitting the code. Then later in this episode, we will be discussing on some data based splitting as well. So initially, we can focus on the code split. So think of a monolithic application where all your entire code resides in a single code base. You have no splitting at all. Everything lies within a single code base, with no splitting based on technical or anything at all. From there, you need to extract the individual area and move that each into a microservice. So how would you be doing that? For that, you need to understand about the domain-driven design. At least a bit of familiarity with that domain-driven design will be helpful. There are a lot of books which features this particular technology in more detail. This domain-driven design in more detail. It actually became popular with one of the book by Eric Evans called Domain-Driven Design. There is another book also there called the Domain-Driven Design Distilled, which has the core concepts of domain-driven design to get you an idea. So I will be giving you a quick overview in brief about the domain-driven design. It's actually a kind of modeling the real-world problem in software. So if you think about software, there are different persons involved in developing the software, like the stakeholders, customers on one side, and on the other side there will be the developers. So these two sets of people use different languages. The customers may be using something that is related to their business domain, something like payment, stock or something. While at the same case for the developer, it might be something like a insert or something, or added to database or something like that. So these language differences between these two people will be a problem when the software evolves. It will be difficult to communicate these ideas into the developers and vice versa. So there involves a set of people in between that's the business analyst, who will be transforming the language of the customers to a language of what the developer understands. Still, there will be difficulty in understanding that. So that's the area where they will be this domain-driven design comes into play. Here, the developer tries to understand the software in terms of business domain. So they will be giving more accurate names based on the business domains for which they are developing the application. In that way, that closely aligns to the language of the customer. So in domain-driven design, take for an example of a shopping website like Amazon. There will be having different key areas that can be identified within that application. So the whole application of Amazon, like shopping website, can be considered of as a business domain. And there will, inside that, there will be different subdomains. Like if you think about the whole application, you will, if you closely analyze, you can have a set of different entities like customer, then there will be something like products, shopping carts, then feedback sections, then sales, then warehouse, many payments, cards, recommendations, then offers, different areas you can identify. So in domain-driven design, initially the software architect or the developers who are involved in developing the application microservice based on domain-driven design first understand these different areas that are related to the particular customer domain. Then they can group these different objects into aggregates. So aggregates is the concept where these different entities that we identified within the business are treated as one unit for the purpose of data changes. That is the explanation given by Eric Evans in his book Domain Driven Design. He mentioned like the aggregates are as a kind of a cluster of associated objects that can be treated as a unit for the purpose of data changes. So the idea why aggregates are important here is that through the aggregates we can understand the bounded context or the areas where areas in the business domain that can be used as a fit for a single microservice component. So initially, once again I will be explain. So initially the architect or the developer will try to understand the business requirements totally. So there would be an exercise called the event storming. There are other ways also by which you can understand the context of the business. You can have a discussion with the business owner, or stakeholders and everyone who is concerned with that business, and then have a full idea of the different of the full business domain, and you then go tries to identify the key areas of that business domains, like the key areas like we understood related to that shopping website Amazon. We have the payment area there. Then there will be a ticket area there, and different entities that are associated with the with entirely that software will be collecting that. So we are not focusing anything about how they are related with each other or anything at this stage. Just we identify who all entities are involved in that business domain. The idea is to get a picture of the business domain from the customer perspective or the stakeholder perspective, and then converting, we are trying to convert that into our technical area. So first we understand the business domain, then the key elements of whoever that is concerned with the business. So if you think about Amazon, there will be a customer there. There will be different items will be there. Then the shopping area will be there. Then there will be suppliers will be there. Then there be payments will be there. Then the invoice will be there. Then the notification that needs to be sent to the customer will be there. Then the payment related service like some form of external bank or something payment service will be there. So everything that is related to that business domain are collected, and that are arranged as a board. If it is in the case of a event storming, it's arranged in the as a small sticky notes, and we identified the entire area. Then the next is like we will these all different sticky notes based entities are a kind of individual ones, and we then try to treat them as one unit. We group some of these entities into one unit for the purpose of data changes. So that is what the Eric Evans mentioned in his book Domain Driven Design. A cluster of associated objects that will be identified from these, and then it will be grouped together, which is called the aggregates. And from the aggregates we can identify from the aggregates grouped together we can identify a relation between each of them, and we can understand the key entities there, like when there is an event that can happen, all the different underlying aggregates or entities are affected by that, and that way we can identify a context there. So if you understand closely these different entities, these aggregates and all, we can form out a kind of a context from all these different areas. Like we can have a context like a payment context, warehouse context, this sales context, customer context, and everything we can form out of that. And then these bounded context is actually what we are trying to convert that into microservices. So instead of the technical grouping as we discussed in the case of layered architecture, here the focus is grouping by business domain. So each microservice component will be responsible for owning one particular context of a business domain, and that will be the main responsibility, and the team who own that microservice, their responsibility is to best ensure the outcome of that microservice component. Keep in mind that there would be different components, modular components in microservice architecture, each owned by a separate individual team, each has its own database, but same time they will be communicating with each other as well. In the case of shopping, whenever some component, say for example an order component which takes the order from the customer, will be contacting the payment microservice for doing payment and all. So this way there will be different components, but they will be contacting via network. So these are not there in a single process as that of a microservice. These will be separate code bases. Separate team will be working on that, and languages can also be separate, but there will be a generic way by which they can communicate with each other. The communication mechanism can be through HTTP, or it can also be through the gRPC, depending upon the context which preferable for that. And there will be also security considerations also in place, because when one microservice contact with the other, it needs to ensure that only the authorized microservice is allowed to contact with other microservice. So there will be security considerations as well. Security considerations we will be discussing on in a further episode. Here we are trying to identify an overview of the microservice architecture in more detail. So this way, when we are creating the microservice through the identifying these entities, these aggregates, and then through the bounded context, and then finally the microservice, we are actually trying to form out a modular component with data encapsulation in place. We are only exposing from that service to other service, or those outside it, only the required elements that other service wants, and we hide all the implementation detail inside that microservice. Take for example, if it is a support microservice which is part of the Amazon website, this support service will be exposing only the required APIs that are required for creating the support, and also something like a notification or something, and all the other details, the implementation details, are there inside this supports my service, and that will be known only to that team who owns that service. That is the key definition here. Here there is no concept of a shared database. So that service, that respective service and its owners only have an idea of how it is actually implemented. This will be beneficial for the software architecture, because the higher you have cohesion or the related areas grouped together, and the less coupling you have with other components. Here the less coupling, how it happens is like you are only exposing through an API only the required elements that other components want, and that way you can have a control over how the other components are getting affected. So that means if you properly identified a bounded context and the different areas and the related areas, and wrapped it into a microservice component, you can have a silo like an implementation detail inside that microservice. It's not accurately silo, it's like an encapsulation. The accurate term is not silo, because silo is a bit occurred in case of an organizational context. So mostly something like an internal implementation hiding or something like that you can call, and that is actually beneficial for other parts of the application, because you can change it whatever way you like. The only requirement is like whatever you are exposed to the outside area, that should not be affected. So whatever you are exposing to the other areas, you are communicating to the other teams, but internal implementation is within yourselves. So that way you can select the best one you like. You can have the best suitable technology that your team prefer for developing that website, and without thinking anything about the other components at all, you can test it that independently as well, and you can deploy it thus. Independent deployability is the key element in microservice architecture. That is what Sam describes in his books. Sam Newman describes in books. Like, you can understand everything about microservice architecture and all things, and you can develop an application, but ask yourself the question whether your software is capable of deploying independently without affecting the other parts of application. That is the key challenge with the key characteristics that distinguish whether your microservice architecture or implementation has become proper. If you are deploying an application and at that time you need to contact the other team like, okay, we are deploying this, you need to make some changes in your side or something, then that means the dependency is still there and the code splitting is not proper. So if there is a dependency for one microservice with another one, that indicates that some form of coupling is still there, and you need to identify that, extract it. Sometimes there might be some form of shared data that exists between these two different components, and you need to coordinate with these two different teams to use that. But Sam described in his book as it's an kind of an anti-pattern. If you have shared codes that is used by two microservices, it will be better to copy it and move it to your own, because that way you don't have a dependency with other service at all. You can have your own libraries, but make sure that you own that particular library and won't allow other teams to change that. So somehow the idea of that dry pattern, don't repeat yourself pattern. So with that context in mind, they ideally try to create a library for something, and that library will be encouraged to reuse by all the different other teams members. So that's an anti-pattern in this case of microservice architecture. What happens is that when you create a library like that, it actually creates a kind of a shared responsibility between two different teams. The ownership will be harder to identify which team owns that shared library. This way it will be a challenge, and if someone is making some change, it will affect the other part of application. So better to have something a line of boundary exists there, so that you own, or your application owns entirely everything, and you copy that all the related codes to your microservice, and that way expose only that API, and other parts are completely encapsulated or hidden for others. They have no need to know about anything related to that except the API you are exposing. That's the way you should be forming the microservice architecture. So these are just an overview. We will be continuing from here a bit more. So let's move into other areas as well. We have understood microservices, an overview. Hope you also understand some of the key characteristics of microservices. Now let's have a look at some of the challenges that are associated with microservice. One thing is, like, as you can see here in microservice, the code is actually splitted based on business domain and it's actually distributed across. That means your simple application instead of a single code base, as in the case of a monolith, or even or for a modular monolith. Modular monolith means a single process can have multiple services, and that can be splitted into different processes. Even when comparing those two type of architecture, the monolith or modular monolith, or even that service oriented architecture, what it differentiates in this case, in the case of a microservice architecture, is here you can see a kind of a distributed architecture with individual components splitted across and communicating through network. That means the testing side, it's a bit challenging. We are now looking on some of the challenges. It's actually not the demerits, actually it's kind of a complexity that is more associated with microservice. These complexities, if you tackled, will be having its reward, but this would be an overkill for a trivial application like a POC or some kind of more modular application. It's a smaller application with a team members of few. This will be an overkill. One thing that you could consider when developing whether to choose a microservice architecture is best fit for a good for your new application or not, especially if you are in a POC stage, is to analyze the business domain in more detail. Try to get more details about the business domain, and like as we discussed earlier, try to find out the entities, aggregates, how many bounded context you can place. And if you feel that microservice architecture would be a best fit for that case, you can have a discussion with other team members as well. Then implementing that would be helpful. And if you are working on a POC, after understanding this, and if you feel microservice is a good choice, then it's definitely worth to start the POC with that as well. Like this is mentioned by one of my friend John, like if you are working on a POC, in reality that POC is going to deploy and will be handed over to the respective teams if it is a success. So if you start off with a kind of a monolith or some form of wrong architecture, and if you hand over that to another team where there is a scope for a microservice architecture, from their part it would be difficult to further convert that to a microservice architecture. I mean at the initial stage. Even though Sam Newman mentions that modular monolith for the monolith or some form of trivial architecture is best fit for a new application, still if you feel that after analyzing the business domain and if it has scope, then considering microservice would be good. If you have more team members and there is a more scope for scalability and evolution of that software, then that would be good to have a POC itself also started in that form of architecture, because whatever you are handed over to the next team, that will be the one next team considering. Okay, let's again continue on the challenges. Cross testing or the final testing of the software would be challenging, because here the components are splitted apart and more effort is required for splitting. So you can have a mock and test these different microservice component, but still it would be challenging and not easy as in the case of a monolith application. So that's one reason why I think once Sam shared in one of his sessions, like one of the company called Honest Update, they have shared a Twitter status that we replaced our monolith with microservices so that every outage could be more like a murder mystery. So if you properly understand that word they shared, that sentence they shared, you can have a understanding that it will be difficult to troubleshoot what is happened behind the cases when a microservice fails, because each has its own database, each has its own state, and you need to coordinate that microservice with other microservice to get a full picture of what is actually happening behind the scene. So there are different ways to tackle this. One is to have a proper log aggregation in place, like something like an application insights or CloudTrail, which captures every detail of different services, and a coordinated logging also would be helpful, so that you can understand as to what events has caused what different outputs from different microservices, and that way you can have a coordinated custom dimension from different microservices, which would be helpful to understand what's happened behind the scene. That's the reason also why Sam mentioned in most of his books, like to have a log aggregation initially is a good prerequisite before starting moving to microservices, whether it's a new microservice or you are migrating an existing monolith to a microservice. It would be better to have a log aggregation in place in advance. Otherwise, it would be difficult for you to understand what's happening behind the scene. And log aggregation is particularly helpful for understanding how a microservice is working and all. It's one of the problem that many will prefer to move a monolith application to a microservice without a proper logging in place, and they think, okay, logging can be considered as an afterthought, but it would become a problem, especially even in the initial stages. It would be difficult to troubleshoot as to what is going on behind the scene. And another thing we haven't yet discussed that is the deployability area. Like we are ideally deploying these microservices to different containers for the purpose of cost effectivity and other orchestration related benefits. We'll be ideally deploying to containers. So containers, the concept of containers is like it can be created and destroyed at any stage, and automatically the orchestration systems like the Kubernetes will automatically spin up a new container instance. So that means you won't have a physical log there in reality. Even if you have something, you can write to a disk file there, and you can log into that container, and you can have a view of what is written there. Still, it exists only for a period of time. For that reason, a log aggregation mechanism like application insights or CloudTrail would be required in advance, so that every events that or every logs that is written into the from the container will be captured, and it can be aggregated to a common location. Then that would be helpful for you to troubleshoot. Relying on a physical log is not effective for a microservice application, because you won't be deploying a microservice instance to a VM or a physical machine, or most of the cases you will be deploying that only for a container, because that's more cost effective. And also another concern that troubles with this microservice architecture is there are a lot of components, microservice components you will be having, and you need resilience in most of the case. Like if one microservice fails, what will happen? Sometimes if one microservice is contacting other microservice for some data, and what if that microservice goes down? Usually you need some resiliency in that place. You will be having multiple instances for each microservice, which is possible in this cloud era. providers like Azure and AWS can have the provision, and these container on-demand container services like AKS, Azure Kubernetes Services, or Amazon's Elastic Kubernetes Services will be helpful also in that cases, but it's not free actually. It will be having a cost associated with it. Then that is also a problem when it comes to resiliency. Then another one area that you need to consider is security issues, because these microservices are independently deployed, each having its own component, and each needs to contact also each other. So there must be a security in place, and there is a scope for a attack on a larger surface area. You need to aware of like that, and you need to constantly monitor each service, and you need to patch and protect that and all. These are all some of the problem, and also the distributed transactions also cause problem. Like everything is happening through network. We expect that okay, network is there while testing, but things goes differently when it goes to live. Maybe the network gets delayed, or network bandwidth get reduced, and it affects the communication between each component. That is also a possibility. So resiliency must be there. Whenever a microservice is trying to contact other microservice, if that the target microservice is down for some reason, it should handle that situation appropriately. Either that should be get retried a bit later, or otherwise you can implement a kind of an asynchronous pattern in between by implementing something like a queue or a topic in between. There are a few on-demand services from Azure and AWS which facilitate those things, like the Azure service bus, as well as in the case of Amazon there is a simple queue service which you can use in between those between the microservices to make it more asynchronous, so that in case if one microservice fails, it can start at a later time with the information there in the queue, and that way resiliency will be there. Also, there are a lot of other issues that you need to consider. All the issues that are associated with the distributed transactions. You can have a search in Google like the disadvantages of having a distributed architecture, and you will get a lot of details there. Most of them are connected with the network. So all those things can happen in the case of this microservice architecture as well. There is a possibility. You need to consider all that while developing microservice architecture. Second is like the eventual consistency. Like there are data resides in different components. So each one ideally have a different database. Each Microsoft ideally have a different database. There are people who advocate that okay, a shared database can be used with a microservice, but actually that is more a kind of either a service oriented architecture or a kind of a modular monolith, and it's actually not microservice. That's one of the key thing you need to understand. Microservice architecture we have its own database for each different component. That means data resides in multiple area. After some point of time in this episode, we will be discussing on the data issues that can arise. We will have a quick look at those things as well. For now, you just understand that okay, data will be residing in multiple area. So if there is a order service, it will have its own database, and data will be order related data will be there, and another one service like something like a customer service or something, it has its own data also associated there. So data might be there in multiple area, and also just like we discussed earlier, the case of a resiliency where you need to have different instances there. So data needs to replicate across these different instances. Many of those issues will be handled automatically by the cloud if you are in cloud. but still that issue of eventual consistency is there. If data is there in a primary database and whether it's replicated to a read replica properly, some time will take. And eventual consistency is like if you are committing something to a main primary database and it needs to replicate to sub databases that are associated with that instance, it will take some time to replicate all those things. It will happen within the seconds, but still the delay is there. So that's called eventual consistency. You can have a search of that and understand more about eventual consistency. That issue also can happen in the case of a microservice. So for this main reason, if your application is intended to be to a smaller group of audience, or it involves a fewer developers, then this kind of architecture is not good for you. Then another thing I like to point out here is, earlier in this episode we thought about the domain driven design and considering aggregates and bounded context, and we identified that each bounded context or a group of related aggregates can be moved into a single modular microservice. But keep in mind that as you progress with the microservice development, you can identify more areas. That is, means even within a bounded context, you can identify multiple aggregates which can be moved it into its own microservice as well. For example, if there is a service like for example a payment service, and it will be having two different areas like the main payments and then the notification area, then you could have the notification itself moved to a different microservice with its own API and all, so that if in case the payment service want to send a notification, then it can contact the notification service and that way it can send. The more modular you can have, the more possibility for you to deploy it individually. So the advantage here it brings is like if you want to change the notification service for some reason, you can have it and deploy without affecting the other area. So there is a possibility that you can bring up modular. That's the reason why we are now going to discuss about migrating existing applications to more specifically the monolith or modular monolith applications to microservices. So we'll start by understanding one particular phrase from Martin Fowler, who says that if you do a big bang rewrite, the only thing you are certain of is a big bang. That means if you try to move a modular or monolith to a microservice with everything splitted and given to different teams and to start development, that will end up in a disaster. So what instead he is suggesting is to move functionality to microservice each part at a time. That way you can get some learning from it and you can move the other parts. So one thing you can do is to understand the entire business domain related to that microservice, that modular application. Once you understand everything, keep in mind that this existing modular monolith, if it's a legacy application, it may not be written with this microservice or this domain driven design in consideration. So you need to understand that from a customer perspective, identify the business areas, and you need to identify the entities, then break up it apart into aggregates, and then finally identify the bounded context. There is a series of practice which you can use. I discussed two of them in the earlier episode, just a brief. That's one is event storming, another one is the seed process. Event storming is one thing that we discussed in this episode as well at the initial stage. There will be more things to understand related to that, but mainly the event storming is to identify the events that are related to a business domain. And we are trying to, as a software developer or architect, we are trying to understand the business domain from the perspective of a developer. That way we understand the business domain, and then we will be mapping those into practice. So we identify the different area. So once you, in the case of the existing monolith application, you can have an understanding of its business area and then identify the business context, the bounded context and all. Then analyze what effect or what benefit you will get from converting this to a microservice. Some of the benefits that you achieve is scalability and independent deployability. You can have more scope for scalability and more scope for individually deploying and without affecting other part of the application. Maybe your application will have a business value, but you feel that okay, if I improve the payment area of my application, it will have a more benefit for my application. Then what you can do is you can try to focus on that payment area and extract that bounded context and move that into a microservice. Moving that to a microservice, you can follow a pattern called a triangular fig pattern. It's actually a way by which you are creating a new system, a new modular microservice, in this case the payment microservice, around your existing monolith application. So you have the support of the existing monolith application and you are creating a new system, modular microservice with side by side of that existing application. And what you are going to think about is this new system actually doesn't need to replace the full old system at all. What you are trying to achieve is you are actually creating a new system for a particular business area like the payment, and you are checking whether that new modular service is actually satisfying our requirements or not. So your customers will be contacting your application. If it's a case of a web application or some whatever form of application, they will be contacting your main monolith application. What you do at that stage is, in this case of triangular fig pattern, you will be intercepting the calls to the system, your modular system. And if you are identifying that okay, particular area of your application has payment functionality that your customer wanted, you can divert your calls to the new microservice module you developed. That way you are intercepting, the basic idea is intercepting calls from the older system and redirecting to the new system. And this way we are diverting the calls and we are invoking the functionality on the new system. This way two things exist side by side, like the on modular system as well as that new microservice system, on monolith system, existing monolith as well as the microservice architecture. So you can have different ways to intercept this, ideally using an HTTP proxy or some form of API gateway that you can put it in front of your existing monolith, and that way you can redirect your traffic to the new microservice which you developed. The idea is intercepting before the traffic goes to the existing monolith, and you will be redirecting that to the microservice which you are developing. This way you can initially develop a small microservice that would be an extraction from your existing monolith, and then as you learn and as you feel that microservice has been successfully deployed to the customer, and if you feel it's working, then you can redirect the entire calls to that service. In this way, both the code exists, like the existing monolith code exists as well as the new one exists, but at the success stage, most of the traffic goes to the microservice only. And at that point, you can work on the next set of services. So this way, incrementally, you are actually rolling out or converting your existing monolith to the microservice architecture. This will be the suggested way because it won't affect anything. So deploying, once you feel that everything is working properly with the new microservice and everything has been extracted and converted to the new different modular service from your existing monolith application, then you can finally remove the existing monolith application. Everything will be served by your individual monolith component. So this is very good for migrating existing monolith to microservices, because if anything wrong happens, you can easily roll back your functionality to the monolith. So because of this, it's advisable to keep the monolith for some more time, even if the new microservice is working effectively, because at customer side or live, at any time something wrong can happen and we can easily revert back. So that's one approach. So this will be beneficial for you to move. Then there are other areas like here what we have done is like in Strangular Fig pattern, we identified the calls to that service to our monolith application through an interception, and we redirect that to something other area like invoice or something. But that is possible for some of the areas of our application. But what about if something is there inside our application? For example, if there is something like a loyalty or something like a rewards, that can happen only when an order taken place or something. At that area, it's not like that we have intercepted and redirected. It's actually the customer needs to contact the main monolith and do some of the interactions there with the existing monolith, and then only the loyalty or reward service can be called upon. So at that stage, how we are going to do? That's a question. Like interception is possible before the application, but this, if suppose if the customer wants to interact with the existing monolith and then want to do a redirect after did some interaction, so how that's going to happen? In that case, what you can do is to create some form of abstraction inside your existing code. Maybe the existing code can keep in that place, but you can slowly create a new area inside your application, like a kind of an abstraction, where say for example the loyalty of reward service, where you can create an abstraction for that loyalty or reward service. Mainly if it's a new application, new programming language like a .NET or Java, you can use interfaces for that purpose, and that way you can create a new interface or abstraction for that new service. The point here we are doing this abstraction is like we will be switching that to a new code, like a kind of a more microservice oriented code. So we'll be calling the microservice module. You will be ideally creating a new loyalty or rewards microservice, and you will be calling that microservice from that abstraction there. To work this effectively, you need to have an abstraction in place in advance. So this is mostly this is also related to the feature toggle. Like we have our existing code and we also have an abstraction, and we will add a feature toggle. Feature toggle is the property by which you will be deploying your code and to the live, and your customer will be having your application with some codes, but still they are not actually released to the customer. So here we are splitting out deployment and release into two different things. So ideally when we say deployment, we think of releasing a software to customer, but here we will be thinking a bit more Like we will be thinking about deploying and releasing separately. So we will be deploying the code which has both the existing code as well as the new abstractions, which a feature toggle there, and we will be deploying that to the customer. And once the customer started using that, we can, for at least for some customers, we can feature toggle. We can set the feature toggle to 1, and that means instead of the code, existing code inside that monolith, it will be calling that new microservice code, and we can ensure that that will be working in proper. The one prerequisite for this kind of implementation, this is called a kind of an abstraction pattern. It is also related to feature toggle. To make this work, you should have an abstraction in your code. Like you can have the feature toggle enabled or set at one place, and the entire abstraction is there. Then it will be beneficial for you or easy for you as an application developer to implement this. Otherwise, if your for example, if your notification code resides or loyalty code resides in multiple areas of your application, it will be difficult to implement this feature toggle. So if that is the case with your existing monolith application, that can happen because these monoliths were created many days ago, and there is a possibility that there won't be any standards or anything like that, so abstraction won't be there. If that is the case, then ideally you should be identifying the different areas that you want to abstract and bring it under a common abstraction, and then implement the feature toggle from there. So these are two different patterns that suggested by the experts like Sam Newman. So these more details about this are mentioned in his book, The Monolith to Microservices, where he defined the way by which we can extract a abstraction from inside a monolith and divert it to a new notification service. So we discussed two different patterns here. One is triangular fig pattern, and second one is like the abstraction, branch by abstraction pattern. So in the branch by abstraction pattern, we are creating a abstraction point inside our code to hide the actual ongoing development. We will be using a feature toggle to switch to a new modular monolith, to a new microservice from the monolith itself. And once we are confident with our new microservice, we will be switching through the feature toggle, through the abstraction, to the new microservice instead of the current implementation. That way we can switch the internal part of application as well. So this way we can migrate both the outside components as well as the inside areas. Outside areas you will be actually intercepting using some form of proxy or through the API gateway, and then redirecting the customer accordingly. Otherwise, internally you are using an abstraction. So I hope this is clear for you to understand these things. And if you are working with existing code, there is a nice book on this topic called Robert C. Martin's Working Effectively with Legacy Code. So that's by Michael C. Feather. So, and it's published by Robert C. Martin series. The book name is Working Effectively with Legacy Code. So it will be having a worth to look on that book as well, so that you will get some ideas about these different ways by which we can extract a microservice. So feature toggle is a good thing to consider here. So I will share you a definition which is defined by in one of his blog by Pete Hodgson. He is an independent software delivery consultant. So he says like a feature toggles, or we also called it as feature flags, is a powerful technique allowing teams to modify system behavior without changing the existing code. He further defines that They fall into various usage categories, and it's important to take that categorization into account when implementing and managing toggles. Toggles actually introduce complexity. We can keep that complexity in check by using smart toggle implementation practices and appropriate tools to manage our toggle configuration. But we should also aim to constrain the number of toggles in our system. So the last point is like, if your code base has codes splitted for a particular feature in multiple areas, mainly if it's an old monolith, you need to abstract that into a single or do some form of refactoring initially to bring that everything into a single area and then implement the feature toggle. Otherwise, feature toggle implementation at various stages using a if-else block will be challenging for you. If it's in a single area, it would be a bit, it's a win situation. Then, so far we have been discussing about the ways by which converting existing application, monolith application to microservice. Now we think a bit about the delivery, how we are going to deliver the microservice architecture. This is also an important thing to consider. Like explained earlier, independent deployability is one key thing which you should consider. Even after developing your application, if you have dependency with other components for deploying, you need to rethink about the way by which your microservice is architected. If you are in a state to deploy it independently, then it would be a big win, and then you can have different ways to deploy it. Ideally, your microservice architecture would be defined in a pipeline with its build and deployment steps and deployed to some form of managed services like the AWS Elastic Kubernetes Service or AKS, Azure Kubernetes Service. Kubernetes, it's an orchestration platform where it will automatically handle everything. You create a microservice, you wrap it as a container, and you will be sending that to or mentioning that to the managed service which you are using, like the Kubernetes, and rest of the things that will be automatically handled by that Kubernetes platform. One good thing that you are deploying this way is that Kubernetes will be spinning up the required instances as you configured, and also in case if something error happens, Kubernetes will automatically heal that instances and relaunch a different one. So everything will be transparent, it will be managed by the service itself, and you don't need to bother anything about the different instances creation and all. Only thing you need to be aware of is like your application should run, inspect of the instances it's creating, and also the log handling, like aggregating logs to a common location using some form of managed services like Azure App Insights or CloudTrail will also be required. Otherwise, it's difficult to pinpoint exactly what's happened. Next, we will be discussing on different forms of deployment strategies. Parallel run is one strategy, just like which we discussed earlier. When we extracting a part of monolith to a microservice, we can have it run parallelly, and we can direct a particular portion of users to that area. Similar way, parallel runs are good fit. You can have your existing monolith application and also the created microservice exist in parallel for some time to understand and study what's happening, whether it's working properly, and then once you are confident, then you can decommission the existing monolith at all. That's one way. Second way is like a form of a canary or A/B testing, where you are actually deploying this to only a particular portion of users. If you have a, say for example, 1000 users, you will be testing that to a set of users like 10 to 15 users, and if you are feeling that it's confidently working there, you will be rolling out to other customers as well. That's called the canary mode of deployment. You can search it both the different ways. So these are the different ways of progressive delivery. Progressive delivery means as you develop your feature, you are deploying it without affecting other part of the application. So if it's a payment related area, you will be deploying that area of that microservice component. If you search for progressive deployment, there are different area, but what you can search of is like a canary deployment, then parallel runs you can check on to get an understanding, then A/B testing, blue-green deployment, dark launching, different ways are there. Then another thing is like you need to have a proper monitoring and log mechanism in place, especially if you are running an existing monolith service as well as payroll service or some form of this microservice side by side, to see where the customers are targeting to and from what service it's actually serving. Is it from your existing microservice architecture, or is it from the new service you created like the payroll or invoice? So you need to understand that. So you need to have a proper monitoring and logging in place at the time of rollout. Then the other things you need to consider is like, so far we have discussed about the ways by which we splitted the code base. This is also what Sam Newman also recommends, like for converting an existing monolith to a microservice architecture. You first identify the boundaries based on code, but you need to consider one more thing, like the data. So how we will be splitting the data? Data actually, as we talked about the encapsulation, data for each service is hidden within that microservice itself. So if it's a shipping database, then shipping microservice, then shipping related data is hidden inside that microservice. Similarly, if there is a returns microservice that is responsible for handling the returns, that related data for returns is hidden inside the microservice boundary. That means each one have a individual database. But keep in mind that this return service needs sometimes the data access from some other services like the customer service, because it needs to know what it needs to return. It also needs to contact with something other like the inventory service as well as shipping service. This is I explaining in the case of an Amazon website. So think about like if there is a returns microservice which has its own database, having its returns related data, sometimes it needs to have information from other microservice like shipping microservice or inventory microservice. So at those times it can call the other microservice and grab the required data. So how it serves the data is also you need to consider. Like we discussed earlier, each microservice exposes to other microservice through an API. So either you can have an expose through the API, or another way is like if any particular microservice owns a set of data. For example, customer microservice owns everything related to the customer, like a customer ID, name, their email and everything. And they will be ideally exposing only some of the relevant informations like the customer ID or something externally. But sometimes, for example, while returns, the return service needs to know where they want to return. So it needs the information of the customer address or something. So at that time it can contact the customer service. But what if there is no API, or if there is nothing related to if there is no API that is there to get the information from that service, then there is another way by which can expose these microservices can expose the data. That's through a read-only way by which these microservices can present a copy of the data so that the other microservices can interact it directly. So that's through a view. So that's a kind of a read-only view of the database that they can expose through an interface. So that way the other microservices can contact these microservices, these customer microservices data without having to go through that microservice itself. So it's like a read-only copy of the data of that microservice which is serving, so that other dependent services can read. But if it is exposed through API, then that way it can expose. But if it's through the API, the challenge is like it should first contact the first service it should return. So that means there will be a lagging there. So to avoid that, you can that individual services can expose a read-only view of the data that they can have. Related to this, Sam Newman suggested that there is a concept called view in the databases. So he mentioned this in his book, Building Microservices. So we can have a read-only view. That's the view. It's a kind of a feature of the relational databases, and if you implement a view, read-only view, then it can have a view of the data your database is exposing. So the customer microservice which owns the customer data can have a read-only view of the data exposed to other microservices, and that way they can grab the data instead of going through the API of that service. This way they can have the data. Then the other thing that are worth considering when it's related to the database is the sharing of the infrastructure. Naturally, when we think about data and having a separate database, many would be coming up with a question like, having a separate database is costly, their license model doesn't allow that. But actually they can have a shared DB infrastructure where a single infrastructure can share the DB, and if it's in the case of a cloud, there are alternative ways by which they can share the infrastructure, shared DB infrastructure, and that way they can the organization can reduce the amount of DB infrastructure and associated admin cost. That means it's actually they're in one infrastructure but having its own instances, different database instances. Then also can have a dedicated DB infrastructure also. That's another option. But there is more infrastructure which needs to manage. So depending upon the requirements that's required for specific microservice, they can have a shared database infrastructure or a dedicated database infrastructure. The one advantage with the dedicated DB infrastructure is like different technologies can be applied. For example, if it's an customer service, it can include some form of database technologies like NoSQL, whereas for transactions like the financial service or return service or something like that, it can use some other form of database technologies. In this way, different combinations of technology can be used for different microservices if it's a dedicated infrastructure. But the downside is like it will bring more infrastructure and more requirements to manage those infrastructure. But on the other side can use different technology, and also it reduces the contention, because if everything is hosted on a single infrastructure, it can create a contention. If one service is using a DB instance because it's a shared database structure, then it can content the resources, like can use most of the RAM or CPU, and it can affect the other services as well. Related to this point, if the customers, if they are using DB on premise, then shared DB infrastructure is worth there because they can reduce cost that way. But on the public cloud like Amazon or Amazon or Azure or GCP or any other cloud provider, you can have much cheaper options, so that isolated DB infrastructure or dedicated DB infrastructure is one thing you can justify on the public cloud. So this way you can have the dedicated infrastructure justifiable in public cloud, while it's difficult for that in on-premise because of the cost factor. Then the information hiding, just like we discussed earlier, when it is related to code, we group every related code in one area. In that way, more cohesion or grouping of code can be achieved, and we will be exposing only the required details through the API to the other areas. We also discussed about some of the exception cases where some other services needs data directly. In that time, we can expose through the read-only way, but keep in mind that only that service which owns that database has the rights to modify that data. That is super important. You need to consider. It's not like even when we think about the earlier example, like where the order service needs the customer data, I mentioned about having a read-only copy or the read-only view of the customer microservice data to that service other than through the API. But that doesn't mean like the order service can directly modify the customer data inside the customer microservice. Only the customer microservice and its ownership or its associated methods only can modify that only through an API code. Otherwise, that way the data will be hidden within that microservice. So the idea here is if an upstream consumer can reach into your internal implementation, it can break the application. So instead of doing that way, you need to expose it only through the API. And whenever there is a change that is happening in the API, you need to inform the upstream customer or the other microservice which are depending on you to inform that okay, these changes has been taken place. There are different documentation methods that are available. You need to have a good proper documentation and coordination in place. Ideally, if you are releasing the APIs, you will be keeping an old version as well there, so that it won't break the existing customers, and you will be releasing only a new versions on top of that. Once you are confident that none of your customers are actually using the old API, then you can safely decommission that. That's the way by which most of the public cloud providers also work on. If they are planning to depreciate some of their APIs, they will ideally track that and they will inform the customer in advance through some public document release or through some direct email. They will inform that they will be moving to a new API. So in this way, once everything has been switched on, they can they can decommission the old API. Similar way, you can follow that in the microservice as well. You can have the new incremental versions upgrade, new APIs, but for some time keep the existing APIs in place so that it won't affect the existing customers. Then another thing which we need to consider is the case of a related data. Like sometimes if we want to have say for example the top best sellers of this week, if the data resides in two different microservices, it would be harder to get the detail from both and then show it to customer that way. So one thing if you join that in the database layer, it will be difficult, especially if it's inside the microservice. So what you can do is like you can create a service in that cases And at the service layer, you can use a join. Like for example, if you are getting the data from two different microservices, and if you want to do a join, then grab the entire data from two different microservices, and at the service layer, you do a join with some kind of server side technologies, and then return that to the presentation or the wherever it is required, presentation layer or wherever it required. Sometimes if it's the data is not real time, then you can save that data to a reporting DB as well. That way you can cache the data and more accurately present the data. This is important because we are actually having distributed data across. Sometimes we need to join the data. So if you try to grab data from one microservice and then get data, related data from other microservice, it will be going through like a loop and it will take a lot of time. Instead of that, grab the data from two microservices all at once, the required data, and then join that at the service layer and then show it to the user. So here there is a pattern called backend framework to frontend is also used. It's also called BFF. So this is especially useful when you want to show data from multiple services to a dashboard. So here what we do is like we will grab all the required data from different microservices, and through a service layer we will be aggregating all those and then present that to the dashboard. This way contention will be reduced in the that microservice layer, and also faster data access can be achieved. Otherwise, one microservice will be grabbing data, then it will be calling other microservice and get data. So as far as possible, whenever there is a request for a join to join the data from two microservices, do it that at the service layer. Also, in the case of the deletion, it will be better to mark the deletions. For example, if you are deleting a customer data and the customer data resides within a customer microservice, so we are going to delete the data. If we are in a situation to delete the customer data, and initially what we'll be doing, the better strategy is to mark a status on the customer table that this customer has been deleted or it's not active. And you also need to keep in mind that here in microservice architecture, the data is distributed across different components, right? So your customer data and its ID may be residing in multiple areas. So what you can do in that case is you can use an asynchronous pattern by which once you delete that data in the main table, deletion means not hard delete, it's kind of a soft delete where you are actually setting a status there, and then you can mention to an event hub or an event topic like something like this customer data has been deleted. Just understand that you are in the event driven architecture, you are actually creating an event, and you are event in the sense like you are mentioning like, okay, a customer data has been deleted. That doesn't mean that other services who are interested in or subscribed to this event data or event hub data need to delete like you did on the customer service. From the customer service side, you actually deleted the data and you put that message in a queue or a topic like, okay, this data has been deleted. Ideally, it would be better to put it in a service bus queue like Azure service bus topic, or not queue, sorry to correct, I'm correcting that, and it's not queue actually, it's actually topic. So there is a pattern called PubSub pattern, so that's the one we were following here when we want to delete something or when we want to disable a customer or something related like that. We ideally delete that in the main table, set that as some form of kind of a status like not active or something. Then we will be inserting a new message into a topic like customer with this ID has been deleted. That means all those other components or different microservices who are subscribed to that topic can choose a decision like whether I should delete or what I do with what we do with that data. So it's up to that microservices. So that point you keep in mind. So you are just saying like, okay, we customer has been deleted by the customer service. It's up to the other microservices to do whatever they want. We can't force them to use a cascade delete as in the case of a relational database. In relational database terminology, usually what you do is like you can have something like a cascade delete, where if you delete from the main table, you will be deleting from all the other table. But that will be a problem, especially with the case of a shopping website like Amazon, where the invoice details and other details needs to be kept there. So once you mark the topic that a customer with, say for example, 101 ID has been deleted, might be a finance or invoice service also be subscribed to that message, and it got a message like, okay, this customer has been deleted, and for that invoice for that invoice microservice, it need to bother anything about this at all. So it not need to delete anything from there. Might be it makes some internal state changes like, okay, this customer has been deleted, and some state updates or something inside that might be, if required, that can do. But while at the other time, some of the other related services like the for example, a recommendation service or something service, if it's using this customer's data, then that can be archived or moved into some other area to avoid the data congestion and all. In this way, these things like a deletion or main events can be appended into or added into an event message, and rest of the interested services can subscribe and act upon as they required. So that's one difference you need to consider when architecting a microservice architecture. Cascading is not possible, and also this lock is also not possible. Some might think like, okay, we can have a lock in place. Like when we delete a customer, initially we will check whether any other microservice is using that data, and if it is not currently using, then we will create a lock and then we will delete that from the main customer. So that is not that brings a lot of additional challenges. So instead of that, better will be to delete that customer if it's not actually required by any of the other services directly, and then they can mark it, and then the rest of the services can take decisions based upon. Then when it comes to microservice, to make the better performance, like we discussed earlier, distributed transaction has its own disadvantages. Like the network is one of the biggest problem that you can experience. So having a cache in between these microservices will be beneficial. There are different kinds of caches, like a server-side cache as well as client-side cache. Each one have its own pros and cons. So let's look at some of the benefits that if you are implementing a server-side cache can have. So if it is for example, if in the case of a Amazon website, the items or the catalog service can have a server-side cache. So the advantage is like, if it is a server-side cache, the invalidation, like how much time the server cache should be kept upon, that can be invalidated easier. So if there is a change in the catalog microservice, that can be invalidated immediately, so that the rest of the microservice got the most up-to-date information from the catalog service. And also it's more efficient in terms of memory. But the disadvantage is like, still the other microservice needs to call this service and get the information. So there is still a traffic that needs to happen there. So think about your application and the ways by which you can implement the cache. So server side cache is there, then the client side cache is there. So client side cache, there are certain advantages. One biggest advantage is like it avoids the network call to the server or other server or other microservice. And also this client side cache is also helpful. For example, if a microservice have a cache in before it actually transmits the data, say for example, if it wants to get some customer data or something, if it is there in the cache, it can get the cache data without actually going through the customer service. And if the customer service is down, this cache also serves as a data source where the customer order service or other service can still work, return service can still work. So that's a benefit. But the disadvantage is like more memory is needed, and also the invalidation is a bit difficult. Like if the customer data is used from the cache, how we want to keep the cache in that client side cache is also worth considering, because if there is a change in the customer data at the customer side, then that needs to get reflected that in the client cache as well. So both of these have its own pros and cons, but one benefit that client cache bring is like the network code can be avoided, and still the dependent microservice can work on. Dependency in the sense like only the API level dependency is there, it don't have any direct implementation level dependency. So there's no coupling is very much less than that of a monolithic application. So that that's the advantage that cache brings to the microservice architecture. So I hope these all give you a good understanding about the microservice architecture in more detail than the earlier episode. I have mentioned a lot of things, like we started from understanding about the partition by technology or the layered approach, and then we moved into understanding more details about the microservices and how it helps an organization. We also learn about the ways by which we can define the service boundaries, and then split the entities, the bounded context, and can move into a microservice architecture. We also understand the importance of information hiding, then the database considerations, and the data hiding considerations and all, and a dedicated database is also we have considered, and also we have looked at some of the deployment ways as well. So I hope it would give a better picture, and I recommend you to go through the books by Sam Newman, which is one of the, there are other books as well, not just Sam Newman's, there are other books related to microservice, but one thing I felt is from, while I understand from him, it's give a more better picture of how microservice architecture actually works, and how it can be related to the modern way application development. So it syncs with some of the ideas that are applied, that have mentioned in the domain driven design as well. So you can easily implement that. When you look at some of the other books, like the other books or other videos or whatever related to microservice, it's focused on that technical area. So there you won't get an exact idea of why this architecture is for. Everyone talks about microservice architecture, but very few know about why it is actually used or what's the need for that. So that idea you would get better from going through the two books of Sam Newman. One book is Building Microservices, and second one is Monolith to Microservices. So have a look at those. Then another one book you can check out is like Micro Frontends. That's also a good book. So going a bit further from this microservice architecture, you can have the option to have individual parts of the front end developed by different teams, and it can be deployed independently as well. So that's the concept that is used in some of the websites like Spotify, where each part of the website is being served by a different micro component. So that kind of architecture is also getting popular. It's similar to microservice but a bit advanced. So here when we discussed about the microservice architecture, the front end we thought of, we actually layered, we sliced the architecture, the full code base based on business domain. It's like a horizontal where an entire domain from A to Z is covered in a microservice component. So there in the front end way, it's a bit different. Like each area of that front end is actually divided further, and that way development is there. I hope we can cover that in a different episode. There is one more thing I want to mention related to this. Right now we have discussed about the way by which we partition the code based on technical, that's layered, as well as also based on the domain, and also we discussed about the database considerations, data splitting and all. Another area we missed is like how the security aspects related to, or the security challenges that are involved when one microservice is contacting with other microservice. What are the security considerations that we can implement? That I hope we can covered in a different episode. With that, I wrapping up this episode. Thanks everyone for listening this episode. Have a great day. Please check my meetup group, Coding Talks Cloud Computing, as well as my YouTube channel. So there will be sessions upcoming. So thank you again for listening. Have a great week ahead. Thank you.